M6C4 homework 1-2, question number 4. Calculate the distance of closest approach for an alpha particle of energy 3.8 megaelectron volts approaching an aluminium nucleus. So from the equation sheet, there's 4 equations that all look similar. We want one for energy, but I'm going to put work done because that's the way, otherwise we'll get confused with electric field strength. And then we're going to have 2 Q's on the top, big Q, little q, and because it's an energy, we have R not squared at the bottom. If we square R, we get something that's got something to do with a force. And we would like to work out what the distance of closest approach is, so that requires a little bit of rearranging here. So the distance of closest approach is going to be big Q, little q divided by 4 pi epsilon naught and the work done. So putting the numbers into this equation, big Q is going to be the charge on an aluminium nucleus, and so for that we're going to need the periodic table. Need to look up aluminium, and it's just here. Aluminium's nucleus will have a charge of plus 13, so that's 13 electronic charges. So big Q is going to be 13 times 1.6 times 10 to the minus 19 times little q is going to be the charge on an alpha particle, and an alpha particle has a charge of plus 2 electronic charges. That's going to be times 2 times 1.6 times 10 to the minus 19. And then you've got your normal constants at the bottom here, so 4 times pi times epsilon naught, which is 8.85 times 10 to the minus 12. And then we've got this energy, which we need to be in joules, and currently it's in mega electron volts. So let's do the conversion down here. 3.8 times 10 to the 6, and the times 10 to the 6 takes care of the mega. And then we need to convert electron volts to joules, so that's going to be times by 1.6 times 10 to the minus 19, and then you're good to go.